This one was a different plant, and it was in Texas. In this story, what happens is this is a large frame gas turbine. The inlet of this gas turbine was basically bringing in the outside air, which was generally dry in this area, but sometimes it would get moist. What occurred, and this was discussed with the metallurgists, was autocatalytic corrosion, and it led to a $22 million insurance claim. The problem with the autocatalytic corrosion is that if you're not looking for it, it's pretty much too late by the time you find it. The typical techniques of doing, say, a dental mold impression of a compressor blade or vane won't find it, because what's going on is when the material comes in dissolved into the moisture of the air, whatever this contaminant is going to be from the outside, when it comes in solution, the first few rows, just as it goes through 0 and 1, it starts to warm up, and then in 2, it starts to get warm enough to drop out and start to plate off in 3 and 4. So as you have these stator rows going in through the compressor, the air gets warmer and the dissolved minerals start to drop out. And when they drop out, they may just sit there and form a little dot. There's no corrosion from that. That's not a problem. Well, the next time moisture comes in and it's just right, this dot will absorb the moisture and then hold that moisture against the little spot underneath of it. Now you start to get the autocatalytic corrosion. More cycles of startup, shutdown, humidity gets on these little dots. Dental molds aren't going to find any problem. What you've got going on the surface is this just tiny little borehole happening, but then underneath you've got a light bulb, like this upside down light bulb under the surface of that compressor blade. So you don't know it. You put your dental mold, your putty, your clay on there, you're not going to find any kind of dent or stress riser, but it's there. And we can talk about stress risers for a second. When you have a long piece of metal and you put a little notch in it, now it doesn't take much force for you to be able to easily break it. That's why your snack bags and everything else have the little tears and cuts in the right spot. Those are stress risers. So this was occurring, and it couldn't have been detected. It eventually led to a blade liberation, and when that happened, the compressor wrecked. We were faced with basically the option of a estimate from one group that said it was going to be $16 million to do the repair. And that was based on their guess as to what they might find when they got into the machine. But they couldn't give us a great estimate until they opened the machine. It cost over $1 million to open these machines. So the decision as to what was going to happen kind of had to be made, before you were going to pull the cover. Well, they also approached the OEM and asked if they could buy another rotor. It turned out there was a $22 million rotor out there, option. The problem was that if some other utility had a similar wreck in the previous week, one of these two sites was going to get that rotor, and it was basically whoever was going to pay for it make the decision first. And our guys had to have some insurance backing that they would do it, and our insurance guys had to know the potential of waiting to open the cover and then losing this $22 million option and finding that your $16 million option is not even possible because you've got a different kind of damage to the rotor in there, and now you need that $22 million rotor, but you have to wait for a new one to be built. So it's going to be a year and a half of business interruption if we don't jump on this $22 million rotor now. How do you convince them of the urgency and give them what they need to feel comfortable that it's a prudent decision for them and for their backers? Well, we did a weighted analysis. We basically said, what's the probability that we got it exactly right? What's the probability that we got it halfway right? And we started putting weights on the parts of what we knew, and then we put less weight on the things like until you pull the cover, you don't know. With that, we were able to show the insurers that there was a large enough chance of unknown damage that could impact the daily business interruption if we couldn't get this $22 million rotor, even if it was only like a 60-40 chance. It shows some weight, towards this business income risk, and the insurers recognized that and accepted the analysis. Actually paid the 22 million. So I think all sides were happy with the outcome on that one. The insurers happy that it didn't have 18 months of business interruption, and the client happy to get back up and running as quickly as possible.